Hi everyone, welcome back to another video in our video series. And I know it's been a really long time since we did one of these, but I promise today's algorithm is going to be really fun, or I think it is. And I promise that if you work with me throughout the end of this to the end of this algorithm, it's going to be well worth your while. So let's get started on it. So today we're going to write a function that takes in a string and checks to see if any anagram of that string is a palindrome. And we're going to return true if it is. If not, we're going to return false. So before we get into this problem, let's go over a few definitions here. For those of you who don't know, a palindrome, according to dictionary.com, is a word, phrase, or sequence that reads the same backwards as forwards. For example, race car is a palindrome because it is spelled the same forward and backward. And also an anagram. An anagram is a word or a phrase that's formed by rearranging the letters of a different word or phrase, typically using all of the original letters exactly once. So an example of an anagram is Iceman. Iceman is an anagram of the word cinema because if you rearrange the characters in Iceman, it equals cinema, or it can be equal cinema. So that is an anagram. So when approaching this problem, how would we solve something like this? The brute force way to solve a question like this is, or the most straightforward and logical way that I initially thought of is, okay, so we're going to have to take every single permutation of the string, because an anagram could be a string that's rearranged in any different kind of permutated ways, and check to see if that's a palindrome. Well, this method is kind of inefficient because if we have a character, if we have a string that's 1,000,000 characters long, there's going to be trillions of permutations, and it's going to be a recursive problem. We're going to have to utilize some sort of backtracking and then do a conditional check to see if each of these permutated strings is a palindrome. And as you can know, this is probably a really inefficient way to solve this problem. So how else can we solve this problem? Palindromes of anagrams. How would we solve this problem? It's important that we look at this problem in outside of the box a little bit in a more creative way. For example, let's first look at what defines a palindrome. What makes a word a palindrome? So let's look at this example here, race car. If we look at the word race car, let's look at the individual characters. So we have 2 R's, 2 A's, 2 C's, and 1 E. So race car is a palindrome, yet it has 3 letters that are even and 1 letter that's odd. Okay, so that doesn't really explain much. Let's look at a few more examples to kind of picture and imagine what this would be like. So let's look at another string, AABB. So is any anagram of this string a palindrome? Well, we can check. One of the permutations of this string is BAAB. This is also a palindrome. We have 2 A's and 2 B's, and this is also a palindrome. And what we could probably decipher is, let's try another one. We could have AAAA, BBBB, CCCC. This right here is also a palindrome because we can actually do, that's kind of really long to permutate, but let's actually shorten this so I can visually show you that this is also a palindrome, BACCAB. This is also a palindrome because, yes, it's spelled the same forward and backwards. And what we can notice about the definition of a palindrome from these characters is, as long as there's symmetry on the left and the right side, so there's symmetry like this and symmetry like this. As long as there's symmetry from the left and right side, it is a palindrome. So does that mean, how do we define asymmetry? Well, we would define it by odd number of characters. But if we only have one odd character, for example, in race car we also have symmetry, because right here we have this symmetry, and a standalone character that is symmetrical. But let's think about this in another way. if, if there were two characters that had an odd count, would that be a palindrome? Let's actually take a look at that here. So let's look at another string, A, B, B, and then C, D. Is this a palindrome? And I'm going to tell you that it is not, because let's make this as symmetrical as possible, A, B, B, A. And then there's two characters here, C and D. And as you can see right here, A, B, C, D, B, A is not spelled the same backwards as it is forward. And there's no possible permutation of this string here with two odd letter counts of the characters that can make a palindrome. So what is the definition of a palindrome, or how can we check to see in a logical sense if a string is a palindrome? Basically, if two or more characters have an odd count, then the string cannot be a palindrome in any form of its anagram. So basically, by the definition of symmetry, if there are two or more characters that have an odd count, 1, 3, or 5, or etc., this cannot be a palindrome. So we basically solved this problem already. This is exactly the kind of algorithm that we want. If two or more characters have an odd count, the string cannot be a palindrome. All we need to do is write it in code. So let's write the code out. We need to utilize a data structure here that can have instantaneous access to the unique characters in the string and also the number of times it occurs in the string. And what's the best data structure to achieve this or to implement this? I would use a hash map, or in other words, an object. So let's do that. The hash map equal to an empty object. And let's loop through the string here. I is less than string dot length, I plus plus. So what we're going to do is first check to see if the object has, the character in it. So if not hash map dot has own property of string of I, then we're just going to say hash map of string of I is going to be equal to 1. Otherwise, we're going to say hash map string of I plus plus, because if it exists in the object already, we've encountered that character before, and all we need to do is increment the count inside of the hash map. So let's actually console.log this just to see that everything is working as expected. So hold on, let me cd into test. So node app, sorry. Okay, so there's an error here. So let me see what's going on here. So if not hash map dot has own property string of I, sorry, there's a typo right here. We could just fix that and it should work fine. So yes, this object now contains two key value pairs, both unique characters of the string and the number of times that character appears in the string. So now we have this logic out. Now all we need to do is loop through the key value pairs and check to see how many characters have an odd count. So let's set a count variable here. Let count equal to 0. And let's loop through the key value pairs. Let key of hash map. And we're just going to check if hash map of key modulo 2 is equal to 1. Then we're just going to say count plus plus. And let's actually console.log the count out, and we should get a count of 0 because both of these are even. So let key up. Sorry, another typo here. Apologize for that. Let key in hash map. Yes, and the count here is 0. So all we need to do here now, I'm just going to console.log instead of return it. So I'm going to say, what was it? So we're going to say, is count greater than 1? Then we're going to say false, else true. Because we're basically saying if two or more characters have an odd count, then it's not a palindrome like we discussed. Otherwise, it is a palindrome or of all the anagrams possible. So let's actually run this. And yes, this is a palindrome because like we said, AABB can be permutated to BAAB, which is a palindrome. Let's check something that isn't a palindrome. So this one right here, we said this is not a palindrome because there's 2 odd characters. And let's run that. And yes, we get false here, which shows that this is not, no anagram of this string is a palindrome. And let's check another one here, race car. This is actually a palindrome, and let's check to see if this one passes our tests. And yep, it looks like everything is working fine, and this algorithm does accomplish what it was supposed to. And this algorithm, this function actually computes to see if any anagram of a string is a palindrome or not. And so that's the end of the algorithm. And you know, this problem set, it was not really hard to code out. It's more of like a brain thinking exercise in which sometimes the most obvious way to solve a problem is not the most efficient way to solve a problem in programming. As in this example, if we tried to permutate each possible permutation of the string and then check to see if each permutation is a palindrome, the time complexity would be ridiculous, not to mention the space complexity, especially if the string has 1,000,000 characters, then we're gonna have trillions or quadrillions of permutations, and that would just be a nightmare and a headache to handle. So this is the most efficient way to solve this algorithm, and that's all. So thank you so much for watching this video. I'm gonna try to post another one as soon as possible, but thanks for watching, and see you next time.